is a very, very powerful tool. All right. And data scientists should be deserving to use that tool. And that is the premise by which we are having these discussions. What is all this? Some feedback. You are talking about the fundamentals. When are you going to jump into core programming in Python, etc.? Everybody wants to, straight away, fly the F-16. They don't want to learn to ride the cycle. All right. In fact, F-16 directly, we want to fly. So this seemed quite apt. All right. So on that note, and also to satisfy the requirements of some people who feedback, when can we start with model building machine learning? We are today starting our discussion on model building. All right. So again, the participants, all the audience who are attending, I'm assuming most of them have done some form of training whatsoever. So we will not be going into some fundamentals like name the types of machine learning models. I think we'll skip that. Rather, I would jump into, like I said, on the project basis and ask Sharath, among the types of machine learning models that are there, which is it that you predominantly used in the project that you had worked on?
Thank you, Nitin. As usual, good evening, everyone. Welcome to the channel. And I hope you all are taking advantage of these sessions and sharing the information, sharing the news with your friends and family members. Coming to the question, what are different types of machine learning models that we can try and use, or predominantly for me, what is the favorite? For my project, I'll again go back to the automobile industry fuel efficiency prediction model that I have worked on. And as part of this particular model, of course, I had built the regression-based techniques, which are under the prediction or supervised learning techniques, because that's what business requirement was. But for your question, I would always say that once the EDA part is done, which we discussed in our previous videos, you can go to the links below and then go through the previous interview sessions. You would understand and appreciate on how important these EDA is for any data processing. And we basically talk about univariate analysis there. But when we talk about data science and when we are trying to understand the information from the entire data set, then we need to also look at the relationship between the variables, right? So I'll just upgrade my univariate analysis, and this time I would be trying to do multivariate analysis, right? So I'm basically not sticking to one column, but I'm going to sticking to multiple columns. And together, what kind of information can I extract? Now here, when we try to do multivariate analysis, of course, we will have to use certain techniques, and I personally call them as the unsupervised learning techniques. Different people might have different opinion about this, but under the machine learning modules, unsupervised learning techniques are going to be very pivotal and critical for getting the right information for even for your prediction models. In my case, the automobile scenario, the fuel efficiency case, we basically performed the algorithm called as clustering, which is unsupervised learning technique. This actually helped me to get the variations reduced in my data set. So homogeneity is something that we wanted to extract. And post that, we went into the supervised learning techniques. So to, again, coming back to your question, my favorites, obviously, I'll first go with unsupervised learning techniques, because unless until I understand what information I'm dealing with in the data, there's no point going into predictions. So unsupervised learning techniques are my favorite, but eventually we will have to go for machine learning prediction techniques.
Thank you, Sharath. Thank you. And friends, that seems to be the logical path. Unsupervised most often times comes first, is what it is. So there's nothing really different, but I would like Bharani to answer the same question, but I want Bharani to take a different take on that with reference to the rationale of choosing unsupervised or supervised? What was the rationale, and how did you go about making that selection?
Sure. Thank you, Nitin, for asking that question. And like Sharad has rightly pointed out, yes, we need to first look at the opportunities of implementing unsupervised learning techniques, especially clustering. And post that, we determine what supervised learning techniques should be applied on each of the clusters or each of the segments. On our project or on my project that I worked on, it was pretty much the same scenario wherein we first looked at the entire data. And when we looked at the data, we figured out that, there was a lot of variance in the data, in at least the numerical columns. A lot of variance means there's a lot of heterogeneity in the data. A lot of heterogeneous data, wide variety of data was coming in. When we have applied clustering on that, we figured out that we got different clusters or segments. One segment was pertaining to, this project, if you remember, was related to heavy construction equipment loan. And who are the people who might default? And who are the people who might purchase or who might take a loan for purchasing heavy construction equipment? It can be small players, startups in the space of construction, or probably real estate agencies. Okay. And then maybe heavy construction equipment, companies which extensively invest in construction. So when we have done clustering or segmentation, we figured out that there were three key segments. One segment was rookies in the space of construction. Another segment was related to real estate folks, and within real estate, people who are mid-sized was that segment. And the third segment was real estate people who had a very large scale. And once we got these homogeneous segments, then when we applied our prediction models on each of these segments, on one segment, one supervised learning worked very well. On another segment, a different supervised learning technique worked well. And on the third segment, altogether a different, supervised learning technique worked well. So given this context, rather than painting everything with the same brush or everyone with the same brush,